This conference will now be recorded.
Okay. Now, can anyone tell me what is RDD? This is the most frequently asking interview question. I want everyone to answer or understand what is RDD, when to use RDD. What is RDD?
It is a resilient distributed data set, which is a collection of partitions, and which is in turn collection of data.
Mhm. Each partition is collection of data. Okay. And let's talk about the features after that. What about the features?
Is fault tolerant.
Immutable.
It's immutable. It's a fault
Immutable.
tolerant. Okay. It's a lazy evaluated.
Yes. Once we call action, then only all the transformations will be executed.
Yeah, that is called
Lazy evaluation.
lazy evaluation. Yeah.
And
What else?
the DAG, it is fault tolerant, so it will reconstruct transformation.
In case of any failure happen.
Yeah.
Very good. It's a cacheable. You need to talk about all these things. Okay. I
Low
think I have
level
given a notes. I have given a notes, right? People might have taken. I mean, notes means you guys have written the notes. This is quite important because the first question from interviewer in a Spark will be, what is RDD? What is the difference between RDD, data frame, data set? These are the questions only. What is Spark? How Spark is different than MapReduce? Okay, these are the questions they'll come. Did we talk about how Spark is different than MapReduce? Did we made a note of the points, difference points? If no, no problem. We'll start again. Okay, that's not the biggest problem. Okay, so let me share my screen. Let me open the. I think I have my machine got restarted. Sorry, why it is it's getting too on. MS Paint starts. Once you're able to see my screen, please let me know. And we were discussing about something, this one, right? Configuration. Okay, let's see. Let me open the program. Today we are going to discuss more about RDD and its partitions. Okay, so by the time it opens, let me repeat that configuration which I was talking about. Spark dot default parallelism, right? Okay, let me copy this information. Look at here. This is the default and this is the meaning. Okay. This is the configure name, and this is the default value and what exactly it means. Okay. So let me copy this one also. Okay. Okay. Let's try to understand. Okay. Before that, let me open this. Look at here. For distributed shuffle operations like reduce by key, join, the largest number of partition in the parent RDD. Suppose the meaning of this is, let's say I have a RDD1, I have RDD1 which has 8 partitions, and I have RDD2 which has 4 partitions. Okay, now when I join these two, when I join these two, like there is a join operation, but I'll show you that how we will do the join operation. When I join these two, okay, the result will come. The result will come RDD3. What will be the number of partitions of RDD3? What is the partition of RDD3? As per this statement, the parent RDD, how many partitions will be there? Those many partitions. It means it's a 3, sorry, 8. And for operations like parallelize with no parent RDD, it depends on the cluster manager. He's talking about to parallelize. Clearly try to remember that. Don't get confused. Don't get confused. This is for this operation. This is for this operation, which I'm going to explain is for this operation. Okay. If you're doing this kind of operations, if you're doing this kind of operation, if you try to do the join, whoever has the resultant RDD will have the how many partitions a parent has, those many. If you're doing operations like parallelism, sorry, parallelize, now the number of partitions will be how it will be calculated. Try to remember, guys. It is totally depends on the cluster manager. Now, coming to that, if it is a local mode, if it is a local mode, when I say local mode, local runner mode, local runner mode. When I say local runner mode, it means all your services are running in the single machine. You don't have a cluster. You don't have a cluster. You don't have a cluster. How many how many cores are there in the machine? How many cores are there in the machine? Those many partitions will be created. Those many partitions will be created. For what operation it is? For what operation? Parallelize. Parallelize. Okay. And for the same parallelize, for the same parallelize, if you are using cluster manager, if you're using cluster manager like a Mesos, or Yarn, the total number of cores on all executor nodes. Okay, let me explain this Mesos I didn't work much, but I'll just tell you. Mesos means by default 8 it will take. But when it come to other like Yarn, total number of cores on all executors, not a single machine here, because it's a cluster. All executors in the cluster, those many are 2. Are 2. Whichever is greater. Suppose if 2 is greater, it will go with the 2. If it is the total number of cores and all executors are greater, it will go with that. Okay. If it is a total number of cores in the executors are 10, it will go with the 10. If the total number of cores in the executor goes 1, it will go with the 2 by default. Whichever is greater. Any doubts so far? Any doubts so far?
Ravi, can you repeat the yarn one?
Okay. Let me. I don't think I can open that. In Yarn, there are multiple executors can launch. Yes, no?
Yes.
There will be multiple executors. Okay. Firstly, try to understand what is the course. Okay. What is the course? Can anyone tell me? Because of
The number of parallel tasks which is running into executor.
in a single machine, capacity of the single machine, how many parallel tasks can run? Or I can say how many parallel processes can run in the course with the help of the course. You can simply see here.
Extra water.
Eh, If anyone is not talking, please keep yourself mute. Okay. Okay. These are the things. How many cores, how many parallel processes can run? Okay. Core 1, core 0, core 2, core 3. Okay. This your chipset. This will be there. With, with the help of this, we will tell how many multiple process can run. Okay. Let me show you. Look at here. Processor cores are individual process unit within the computer central CPU unit. The process core receives the instructions from the. I mean, that's a different story. It is where you can write, where you can write, where you can execute, how many number of parallel processes. Based on number of cores, you can decide that. Based on number of cores, you can decide that. You got that point? Yes or no?
Yes, Ravi.
Yeah. Okay. Let's move on to. So, if you are using Yarn, Yarn means what is it's a cluster resource manager, right? It's a cluster manager, I can say. What it does, it allocates the number of how many machines you want for your process. It will allocate those many, and each machine will have some set of cores, and those cores collective of few cores we will call one executor. 4 cores, 5 cores will call one executor. These details will be come to know in the coming sessions. It's too early to talk about it. So if I even explain that, it will not go into your mind. Okay. So like 4 cores we will call one executor. Let's say I have a machine called I have one machine with a 16 cores. I have a machine with a 16 cores. 16 cores are less, okay, in the competition world. If I have a 16 cores, one core I will leave for our CPU or operating system or other stuff. There will be 15 cores. These 15 cores, what I do, the rest is 15 cores. Then what I do, I will allocate 3 cores, one executor I'll specify. So now you guys tell me for the single machine, this is the one node, okay, node 1. Now you tell me for this node, how many cores will be there? Sorry, how many executors will come? How many executors will come?
2.
No, 5
No,
Five.
no, 1,
executors will
1.
come, right? How it is
5.
1? 5, right? Rest is a 15 cores.
Okay.
3 cores, 1 executor. 3 cores, 1 executor. It means 15 by 3. Rest is 15, no, 15 by 3. It's a 5.
Right.
It means 5 executors will come. For how many machine? For one machine. For one machine, one node. For one node, which has a 16 core machine. Which has a 16 core machine. So it means one node can have multiple, one node can have multiple executors.
Executors.
You got this point? Like that, your yarn can define multiple nodes. Your yarn can define multiple nodes based on the size of the data, based on the number of the resources are available. Okay, it will allocate the number of nodes. Okay, when it allocate this number of nodes, based on this configuration available, and this will be now yarn is cluster manager who actually bring the resources for the job, scheduling the job, monitoring the jobs. In case of failure, anything happened, relaunching that, and all will taken care by your yarn. And executing the jobs also will be taken care by yarn only. Cluster manager. So we'll discuss in detail about the yarn. I think it's a little this is the right time. Okay. So the process like MapReduce and the Spark, while discussing this kind of processes, we need to discuss about the yarn. We'll discuss about it. Okay. Yarn is cluster manager. So let's say if I'm using yarn, that time also total number of cores in the all the executors all the executors all the executors are 2, whichever is greater. This is for the parallelism operation. If you are reading file read and all, if you're doing a file read and all, try to remember this is the most important thing. If you're doing a file read and all, if the file is from local file system, actually the partitions will be created based on the blocks. How many know that? We discussed about input splits in initial discussion of MapReduce. Input list, number of input splits equal to number of mappers, and most of the cases number of input splits is nothing but number of blocks, correct? So if the file is in local file system, then the block size is 32 MB. If the local file system, the block size is 32 MB. It is also there in the one of the configuration, but I didn't remember the configuration. Um, I'll search for it. If I find it is well and good, but some configurations will not be there in this file. That's also another problem. Local file block size. Block size. No, not 32 KB. That's a different one. That's a compression one. Okay, not this one also. No, not this one also. There is some clearly there will be something called local file block size. I'll show you. If it is a local file system, clearly it has mentioned. I have read it. 32 MB. No need to read. I'll explain you. I can show you I can show you an example also. If it is a local file system, that's up 32 MB. How to change the input block size in the this is a DFS. Okay, that's a different one. If it is a local file system, 32 MB, I have seen the configuration and also I did it. Okay, let me show you the no need to search for the configuration. We can directly check in. Local file system block size. Clearly they have mentioned the capital letters. It is there. Somewhere it is. Okay, I'll do one thing. If I find it, I'll share with you guys. But it is, I'm very much sure. Let me Let me show you that. Okay. Okay, no problem. Let me launch my Spark shell. Okay. In the last example, whatever we have read a file, and we check the partition number of partitions. It has only 2 partitions, correct? Okay. Let me show you the same thing there. And also I want everyone to please practice the programs like word frequency or word count or whatever it is. Try to understand the logic behind it, because people may ask an interview similar kind of thing, not exactly the word count, but a similar kind of thing. Okay, let me show you this. I'm going to read it. I have read it. I have read my text.dd. Okay, so let me print the number of partitions. I don't need to use the println here, directly I can write. Okay, the number of partitions are 2. Number of partitions are 2. Sir, you said number of partitions will be number of cores, but it is a read, the file read operation. It is not a parallelize operation. If I do the parallelize operation, let's say val data equal to, okay, array to 10. Okay, let's do one thing. So data val rdt equal to sc dot parallelize data. If I say rd dot get num partitions 8, I read file here. It's bigger than these numbers. This is just 1 to 10, but this file is bigger than 1 to 10, right? But here only 2 partitions. But here only 1 to 10 values, 1, 2, 3, 4, just numbers. But the partitions are 8. But here partitions are only 2. Okay. So where the difference is coming, the type of operation we are performing. Above one text file, below one parallelize. Let me show you the same thing. I have one bigger file. I have a bigger file. Okay, let me show you this. The file size is I'll tell you where it is in drive data, right? Just copy this path. Look at here, guys. This bigger file, the size is 261 MB. 261 MB. Okay, I'm going to read this file. 261 MB. This is the file I'm going to read. Okay, it's a bigger file, not 32. I mean, so now, as per my calculation, I'll see 200 261 modulo 32 MB. So I should get 9 blocks. 8 point something means 9 only, right? There won't be 8 blocks, 8.1 block, it won't be 8 blocks. After that, even those 1 kb or 0, I mean 1 kb also, it will be a different block. So 9 blocks I should get. 9 blocks I should get. How many blocks I got? 9 blocks. What operation I have performed? Text file. What operation I have performed? Text file. You guys can do an experiment. Take simple exactly 64 MB or exactly 32 MB file, read it and see if it is lesser than 2 partitions. If it is lesser than 2 partitions, it will create 2 partitions. If it is beyond 2 partitions, if it's more than 2 partitions, it will give that value based on the top, whichever is greater. Whichever is greater, it will give. Try to take a 90 MB file. Try to take a 90 MB file and see how many blocks will come. Is this clear? Is this clear?
Yes, sir.
I'm very much sure, guys. If it is a local file system, the block size is 32 MB. I have read it also, one of the article, but I'm not able to find it here. But it is there. That's there. The configuration value is there. Okay. And also the clear experiment, it can clearly shows. Don't get confused. Why it's showing only 2? Why it's showing a parallelized 8? Because the type of operation we perform. If you're performing the parallelize, number of cores available in your machine, those many it will come. In the cluster, those many it will come. If you're doing a text file read or read operation, anything, it's any read operation based on the block size. The same file, it is a 261 MB file, right? Same file, if you read from the HDFS, because I'm in Windows machine now, I cannot connect to the HDFS, so it won't allow. If I'm reading from the HDFS, can anyone tell me how many blocks will be there? So file read, if it's a local file system, 32 MB. Then the block size is, how much is the block size, guys?
128.
So how many blocks will come for 128 MB? So for the 261 MB, for that file, how many blocks will come?
3.
3 blocks.
You get 3 blocks. 128 MB, 120 MB, 256. But we have a 261. So it will be two different. So 3 blocks will come. I hope it's clear to everyone. The partitions and all. If you want to see which partition has what data, if you want to see which partition has which data, let me do one thing. Here only, let me create more. Okay, this is my data. This is my data. I'm going to show you the number of partitions for this data. Sorry, should be, it's just a data, right? I didn't do the parallelize. I did the parallelize. how many partitions? 8 partitions. If you want to see the each partition's data, try to remember it. Each partition data, look at there. Look at here. This is the first partition. First 4 values are there. Second partition, 4 values are there. Fifth partition, third partition, this many. 1, 2. Okay, let me take this. If you are clear about the partitions and other stuff, whatever the question in the interview people ask, you can easily answer. That's what the reason behind it. Array is here, it's representing collection of data. Okay, partition also collection of data. That's the reason it's representing array. Partition is nothing but array collection of data, right? So collection of partitions is nothing but your RDD. If you see, this is RDD, outside one. This RDD is nothing but a collection of data, collection of partitions. Each so outer array. These are all inner arrays, guys. These are all inner arrays. These are all inner arrays. The outer array, we'll call it as a RDD. RDD is nothing but a collection of partitions. Each partition is nothing but a collection of data. These inner arrays are partitions. 1, 2, 3, 4, 5, 6, 7, 8. 8 partitions. So array is nothing but collection of partitions. Each partition is nothing but collection of data. Is this clear? Is this clear?
Yes.
Yeah, Ravi.
Okay. Yeah. Any questions so far? Any questions, please?
So what will be the number of partitions if I want to read a file from S3 bucket?
S3 bucket also is 128 MB. S3 bucket also 128 MB. It will consider as a HDFC block, HDFS block.
Okay.
If you are reading from the RDBMS, it's the 32 MB. If you are reading from the RDBMS, any of the database like Oracle, MySQL or something, it will consider 32 MB. Okay. If you're reading from Kafka and all, how many messages will come in the in that interval? There will be something called batch interval. How many messages come into that one batch? One batch will be considered as a one block. We will see those things in further. But for now, whatever we are going to learn, like either file system, either HDFC file system, or you'll be learning from local file system or parallelize operation, these things only, right? That's the reason I'm showing this. So reading from the RDBMS and all, I'll show later. We will check that. Any questions? Okay, let's move on to the next program. I'll try to explain the program again today. This is quite important. I don't want everyone miss this. Okay, first you have to write your object. So whoever has gone through our Scala training, so they will be knowing it. So object is an entry point. Suppose if you're running your program, so that will go for the respective object class, then I cannot call it as object class. It's not just an object in Scala. Okay, it's just an object. We'll go to the object. Then in that we'll have a main. That we have a main method. It's an entry to our Scala application. It's the main method is execution start from the main method. It means it's entry to our Scala application. Coming to we have to create our Spark session and Spark context. The reason behind it is these are we'll call them as a driver programs, and that is an entry to your Spark application. Without having Spark context or Spark session, you cannot execute any Spark program. Without Spark session or context, we cannot enter into Spark application. We will not get the Spark environment. We cannot get this sparkness of your program. Okay. Suppose if you are without using this, and if you are reading collection of data, in Scala also we can read collection of data. That's something like Scala collections, like a list array, or a sequence, or a vector, or set, or map, or that kind of collection only. That will not get the sparkness. There won't be any partitions. That will execute only one machine. So that kind of differences comes. Okay, we'll read a file. This is a word frequency program. To understand that word frequency program, okay, we read the file. I'll just show the partitions here. We need to split it. Why we need to split it? So when we read a file, the RDD is nothing but collection of partitions. Each partition will have a collection of data. How the data will appear? Let me show you here also an example with that. Let me show that for example. We read a file RDD, right? It's the file RDD, I think. Oh, it's not a file RDD. It is RDD. No problem. I'll take a small file, guys. So bigger file again, it may take longer time. Text RDD, right? Text RDD dot gloom. Actually, gloom help us to show the data in each partition. Okay, collect. It cannot show the completed data. Okay, it cannot show completed data. Why? Because look at your last dots. It's a console, right? So it has a limit of memory, how much data it can show. So this is also, you can just assume, you can also see array of array. And each array contains what? Line. Each array contains what? Line. Complete statement, one line by line, right? So as per your example, this data, let's assume that this comes under one partition, or let's assume that this four lines come under one partition. This 4 lines comes under one partition. Just giving the line here. Let me give just for example. Let me do one thing. So you got above one is one partition, below one is one partition. Let's assume that. So in this partition, your data is like a line by line, correct? Line by line. Line by line. This is also line by line only. Line by line. Okay, if you want to divide this, I can divide it. So let's see. Line by line, we have a data. If it is a line by line data, your Spark will read line by line only. So based on the kind of operation we perform. Here, I did the flat map. I'll explain flat map and other stuff in the next session, but it's a too less time we have. So to explain you in the detail. So I'll explain the next session. If you look at here, flat map I did. What the flat map will do, I'll tell you simply. What the flat map will do, it will read a line. Element here is nothing but line. Okay, I can keep it as a line. Let me keep it as a line to make you guys understand. It will take the line. I'll read the line. When I read the line, I'll get the complete line like this. I'll get this complete line. I'll get the complete line. as a first iteration. Okay, I'll do one thing. I'll show you here. As a first iteration. Iteration means first loop. As iteration 1, it will take the first line. After taking the line, what is the operation I'm applying? Split operation. I'm doing the split operation by this. So what it does is split by gaps. Look at the space. What are the space you have? It will split by this space. So I think I don't know how many of you did the split operation in the strings. Okay, the split actually returns your array. Look at the syntax. String, public array, string array. Okay, the split will return string like this. Okay, it will return like this. You may have an examples in this. These are all source code. Okay, these are all not something I have written. It is there already. The source code, which actually help you guys to learn. You guys, did anyone open this? I mean, I used to keep show this one. I don't know how many of you are opening and going through it. Uh, how many are going through this kind of APIs? This APIs. Whatever the information you are finding here, right? See, let's take a flat map. Whatever the information you're finding here, right? That information only the source files will be there. Similarly for Java also. Okay, Java API documentation. Okay, let's say I'm interested on a string, correct? So I was looking for a string, right? So that will be there in the lang package. Java.lang. So string, I'm looking for a string, right? Look at here. So what is a string and other stuff? And the split method, right? I was looking for a split method, right? Try go through the documentation instead of going through this block, that block, because the blocks, let's say block will be right like me, the person like me. So whatever my understanding, I'll put into my block. Okay, that may correct, may not correct. I'm not saying everyone is writing a wrong blocks. There are some blocks may give their understanding. That's not also his fault. He's not purposely doing, he has to give a wrong information. That is his understanding. If I start writing my block, what I do, my understanding, I'll put in the words. Okay, so if you start read these kind of API documents, if you start read this kind of API documents, you will understand in complete details, right? This, whatever the information you're seeing here, no, the same information only will be there in the documentation. This one, the same information. This is for the developers purpose. Okay, they will understand the things and they will uh, actually they'll understand the things and they'll implement. For that purpose, the APIs will be there. Not only this API, you have a similarly Scala API. Similarly, Spark API also there. Spark API also there. How I shown the configurations? How I shown the configurations here? Similarly, you have a whichever the language you are using. Suppose you are using Python, you have a Python API. Suppose if you are using Java, Java API, Scala API. Let me show you. This is Python. This is Scala. Okay, you want to understand what is RDD. Let's assume that you want to understand what is RDD. Okay, let's say this is RDD. This is RDD. Okay, this RDD documentation. Clearly, you can read clearly here. A resilient distributed data set, the basic abstraction. I told you, no, primary and basic abstraction Spark represent the immutable partition collection of elements that can be operated on parallel. It can be processed parallelly. That's the meaning of it. This class contains all blah blah blah, blah map, flat map, filter, and so on. I mean, this kind of transformations. Okay, you can see here, and it's internally characterized the 5 main properties. I'll show you these things. List of partitions we already shown. The functions are computing each split. So whenever the partition created, there will be something called compute method. It'll call it. Okay. If you want to see that, you can see this also. List of dependencies. These are partitions. So this is the information. So if you read this one, right, you really no need to go for any blog, not blog, any blog. Okay. So, but what I can say, there will be some terminologies you may not be able to understand. So you can just try go through it. But anyway, I'm explaining in the classroom. Later, you guys can go through this kind of documentation, like it's given by Spark. It is not prepared by someone. It's a Spark's own, right? It's not someone like me. It's someone who developed the Spark application or who introduced, who are the part of the contributors. They're developing it. Okay, and this is a Spark Git. If you want to get the Spark source code, this is a Spark Git. Spark has its own Git. Okay, so Git, you can see that you can open any class if you want. You can open whatever, suppose data frame, suppose RDD, whatever you are learning, you just open them and you can read it. Okay, how they have written the Spark code. The same documentation which I shown in the other page. Class RDD. I said no, it's abstract. It's abstract. Okay, you guys can go through internal things like, okay, compute method. This was I was talking about. I'll show in the detail later. Okay, it says a compute method, get partitions, get dependencies. Is there any dependencies? Okay, let me show this one. But get dependencies are not directly calling, it will be calling from some other place. Get partitions. One second, let me do some small operation. Okay, I want to see because it's a base RDDs. These are all base RDDs. That's the reason it is not showing you guys the other methods. Let me do this operation. Let me do a couple of operations. Okay. Which API we are referring? Which version of the API we are referring? 2.4 only. What is my Spark version? 2.2. Is it because of that? Okay. Ashok,
Yes, sir.
you have a 2.4, I think. Recently we installed in your machine 2.4, correct?
Yes, yes.
Have you created any RDD?
In command prompt?
Yeah.
Yes, sir. Not today, but day before yesterday.
Can I make you present it? I just want to see whether because it's a version issue or why not it is showing the methods. I just want to check.
Okay.
Are those methods, but even though it should show. This is a very big file. I don't know. It will come down. Okay. Anyway, get partitions, get dependencies, get prefer locations. These all will be there. Okay. So these are, I mean, these are all persist. They're all the methods which we can apply on the your degree. This is everything whatever we are using in the background. It's a code. It is a class or it is a object or something is developed by using Java or Scala. Okay. So as we know that the Spark is developed by Scala, that's the reason these are all Scala code. Get storage level. Why it is not showing all these things? Storage level also we can see now. Look at here, get storage level. Default will be memory only. Okay. Okay, we'll see that in detail. Have you started? Ashok, I just want to confirm.
Yes, sir.
Ashok?
I-
Okay, let me make you presenter, then we'll wind up with that.
Sure.
Can you share your screen?
Yeah, I just shared.
What is the exception?
No, this is I opened Python.
Okay. Okay, quickly create an RDD. sc.parallelize. Yeah, you can press tab, automatically it will complete. Okay. Yeah.
Yeah.
Open the bracket. Array, ARR, AY, array, capital A. Okay. AY, bracket open. Just give 1 to 10, 1, 10, 1, 2, 3, 4, 5, 6, 7. Okay. Press enter. Okay. RDD1 dot. Just dot. Just type get and press tab.
Get no
Okay, you're
partition
also getting the
get.
same method. You're also getting the same methods, right? I'll just check. So what is the difference behind it? Actually, the parallelize also should come. Text files also they should come. Let me do one thing.
I stopped screens.
Yeah. Maybe those are not the straight direct methods. Okay. Anyway, so that's how the internally the code is prepared for every RDD or data frame or whatever it is. So whenever we are going through that code, if you didn't understand any of the method or any of the things, try open that and go through. So I was explaining this, right? So it will take the line. I have used a split method. What the split method will do, it will create an array. Out of this, it will create an array. That's a string array it will create. It will create string array. Equal to, it will create a string array. I'm just making a note like this. These are all different elements. These are not the single elements. There will be different elements now. There all will be different elements. There all will be different elements. Now, what this method did? This method read the line, broken, and return collection of elements. After this, what will happen? This RDD contains array of this single array, because I have used a flat map, it will be single array. After that, next line also will come one more array. Third, next line also will come one more string array. So what it does, the flat map has a capability. It will do the flattening it does. So array of the elements will be there. Then what I'm doing, I'm taking every element like this, every element, comma 1, this comma 1, this comma 1, this comma 1, this comma 1. Because in the next level, I can do the count. I mean summing. Count means summing. So here I'm doing the reduce by key. Here the key will be this, right? This word will be the key. See, after this statement, how it will become, after this statement, how it will become, I'll take some samples. So Amazon, comma 1. This is one element. Next, EC2, comma 1. Because that's how I'm creating my return value. Okay. Similarly, this one also, comma 1, it will come here. Similarly, A, comma 1. Similarly, wide, comma 1, it will come. This is how the values come. Once this is come, in this, what is the key? What is the value? This is the key. This is the value. This is the key. This is the value. So I'm applying the reduce by key operation. Reduce by key operation. I'm summing it. So what I'm summing? This one. So there are some cases before it does the reduce by key with the Amazon, comma 1. Let's assume that there is one more Amazon, comma 1. Then let's assume that there is one more Amazon, comma 1. So then what it does, it will concatenate only one Amazon, 1 comma 1 comma 1. So then it will do the summing. That's what we discussed in the earlier session. Then output I have written into the file. So that is for today's session. If you guys have any questions, please ask me. Else we can leave for the day. We'll connect in the next session and we'll start the RDD operations. Okay, like what is map, flat map, all the stuff we'll be learning. Any questions so far? Any questions? Okay. Yeah, if no questions, that's it for today. We'll connect in the next session. We'll discuss in detail about transformations.
Thank you.
Thank you guys. Have a wonderful day.
Ravi, I have
Yeah,
just one question.
please go.
Uh, as you were talking about executor core and other things, so
Mhm.
if you have any blog or any document where I can understand in a little bit deep,
We will
so
be talking about them in the coming sessions, ma. I'll give you the blog. I'll give you the documents also. Okay.
oh, okay, sure.
Yeah. Thank you.
Thank you.
Thank you,
Anyone
Ravi.
else has any questions? Okay. Thank
Ravi,
Thanks, Ravi.
you. Yeah. Yes, Uma. Go ahead.
so here we got two partitions, right?
Hmm.
Uh, so in the first partition we have Amazon, comma 1, and the second pair is there in the second partition, like
No.
Amazon 1, one more Amazon.
Okay. Okay.
So how does the shuffling is happening here? Like
That is what the reduce by key operation. No. That is what the reduce by key operation does. Internally, it will bring all the unique keys and collects the respective values.
so here A comma B we are doing as A plus B, right? So A is referring to key and B is referring to value. But
No.
here we are
No. No. You didn't understand that method properly. Uh, reduce by key, what it does here, A. Okay. Yeah, I'll put you in details in the next session. Okay. Here, let's take an example. Amazon. After this, when it comes to here, Amazon is the key. Values will be like this.
oh,
Okay.
okay.
Values will be like this.
Mm-hmm.
This will be your Amazon. In this, when I do the reduce by key, I'm trying to
Mm-hmm.
do by key operation. So what it does, it takes the only value part.
Mm-hmm.
Okay, after taking into the value part, what it does, this is the value part, right? What this your reduce by key operation does, what is the function I have written here? A comma B. This is doing A plus B, correct?
Mm-hmm.
This I have explained already in Scala. Okay, this operation what it does, first iteration 1. So we need to always understand iteration by iteration. So if you try to understand directly, it will not get understand. So A will be the, B will be this value. Okay,
Mm-hmm.
in the iteration
Okay.
1, A will be this and this. After summing, what is the output?
2.
Okay, the next iteration, iteration 2, A will be 2, B will be next value, this value.
Mm-hmm. Okay.
Now what will be the output?
3.
In iteration 3,
Again 3 comma 1.
3 comma
1.
this one.
Mm-hmm. Okay, okay, I got it.
Okay, this is how it keep on goes. Now we'll get
Okay.
4, right? The iteration
Mm.
4,
4 comma
this one,
1.
it will take this one. Okay, 4 comma A will be 1, A will be 4,
Mm-hmm.
4 comma 1.
Okay, okay, okay.
So it will be 5.
Mm.
Last one is 5 comma 1. Iteration 5, it will be A will be 5, B will be 1.
Okay.
So total will be 6.
Mm-hmm.
So Amazon appears 6 times. 1, 2, 3, 4, 5, 6. Yeah, correct. So Amazon appeared 6 times.
Okay.
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 Yeah. Thank you. Anything else? Okay. Thank you guys. Bye.